Alright gents, so this is a little video about reactions of acids and the ones that you should be aware of. So if we look at our first reaction, which is a reactive metal plus an acid, then this is our what I refer to as a bangers and mash reaction. So we have M, which stands for our metal, A, which stands for our acid, S, which stands for the salt, and H, which stands for hydrogen, which gives us our bang when we do our pop test. So, if we take an example, let's say we take a reactive metal such as zinc, and I react that with hydrochloric acid, then it makes a salt and hydrogen because it's reactive enough. Okay, so what's the salt? Well, we've seen this before. We take the metal, that's the first part of the salt, and then the second part of the salt comes from the hydrochloric acid. So it makes a chloride. So hydrochloric acid always makes a chloride. Now, the next step that we need to do is we need to look at the formulae of these. So the formula for zinc, or the symbol for zinc I should say, is simply Zn. And the formula for hydrochloric acid, you should know, is HCl. Now, hydrogen is simply H2, and already you should be able to spot that there's a little bit of a problem. If we look at hydrogen, all right, the subscript 2 denotes that we have two hydrogens here, but on the reactant side we only have one. So if I put a 2 there, then that remedies that situation. Now, if we have a look at zinc chloride next, there's two ways we can go about this. First off, with what we've done already, you can see that we've got two chloride ions, and yet we've only got one zinc. So that to me is suggesting that the formula of the salt should be zinc ZnCl2. If you're unsure of the charge on your ions, you can go and check your table of ions. So if we come up here, I'll have a look for zinc. There is zinc, which indeed is Zn2+, and here is chloride. Okay, so if I now go back to this reaction, you should be able to see that if I have Zn2+ and I have Cl-, I need the charges here and here to add up to 0. And the trick that I've discussed with you already is if we take a number and move it down to the other ion, then that gives us the formula for our salt. So you should be able to see that the formula for zinc chloride becomes ZnCl2. So let's write that in. ZnCl2. Okay. So there's an example of a reactive metal. Remember that copper, silver, and gold do not react. All right? So they don't react. Okay. Next. Alright, so the pattern of reaction for metal carbonates is if we have a metal carbonate and an acid, then what they give is carbon dioxide, water, and a salt. So let's say this time we take, let's take sodium carbonate. Just make this a bit bigger. So we take sodium carbonate, which is in a sodium carbonate. If I react that with sulfuric acid, then I get carbon dioxide, water, and the salt, which will be the metal. So it's going to be sodium, and it's going to be the acid, which gives the second part, which is sulfate. Okay, so sodium carbonate, we need to really look at our table of ions to work out what the sodium ion is and the carbonate ion. So let's go have a look at those. So sodium is here, and the carbonate ion is actually over here in this other table because it's a polyatomic ion. Alright, now a polyatomic ion simply means that there is more than one atom which makes the ion, and you can see that in carbonate because it's got carbon and 3 oxygens which make up the ion with a charge of -2. So let's go back and let's have a look at what sodium carbonate should look like. So we've seen before that the sodium is Na+, and the carbonate is CO3 2-. So if you imagine for a minute the number up here, 2-, then what we're going to do is we're going to bring that down and put it there. Okay, so what we'll do, just get rid of that, and put R2 there. Now, sulfuric acid, you need to just know it, so that's H2SO4. And sodium sulfate, we know, is sodium is Na plus. What's the sulfate? Right, okay, so the sulfate, we can work that out in one of two ways again. So first off, if I come up to here and I go to my polyatomic ions, you should be able to see here is sulfate, SO4 2 minus. Right, we already know what sodium is, so let's come back down here again. And sulfate is SO4 2 minus, so if I put the 2 there, then that gives me my sodium sulfate salt. Then I simply need to add to that the other products, so carbon dioxide and water are my other products, so CO2 plus H2O. Now, I need to check that this is balanced, so I'm going to switch to blue here and just count up. So sodium, I've got 2 over here. Sodium, I've got 2 over here. Excuse me. Carbon, I've got 1. Carbon, I've got 1. Oxygens, I've got 3 here, and I've got 4 here, so I've got 7 altogether. So oxygen equals 7. Over here I've got 4 here, another 2 there, and 1 there, so that's 7 as well. It's looking good so far. And finally, the last atom that we need to check is hydrogen. We've got 2 there, and we've got 2 over here. All good. Right, lastly, let's have a look at the reactions 3 and 4. So this is a metal oxide and a metal hydroxide with an acid. These are essentially neutralization reactions because they produce a salt and water. So if I have something like copper oxide or sodium hydroxide, and I react them with an acid, so this time we'll use nitric acid, which is HNO3, and again you just need to learn that, and we'll do HCl with the last one. Then we make a salt and water. So again, same process. If I want to know what the salt is, then I need to go looking firstly for copper and then for the nitrate ion. Once you've found those in your table of ions, you should notice that copper has a charge of 2+, and nitrate has a charge of 1+. So what that means is my number 2 from my 2+ in copper is going to end up down here. So that's copper nitrate, and of course we make water. Now if you look at this, we've got 2 hydrogens here, we've only got 1 here, and we've got 2 nitrates here and only 1 here. So if we put a 2 here, then that equation is balanced. Similarly with the one at the bottom, if I take sodium hydroxide and react it with hydrochloric acid, then I make sodium chloride and water. And again, we can find those in our table of ions. Hopefully that helps you, boys. Good luck.